Good morning, good day, good evening, dear ladies and gentlemen, dear friends. My name is Anton Kaneluk, and we are continuing the video blogging series at kaneluk.com. Today is not like a standard video blog where I invite the guests to discuss certain topics. I don't have any guest, unfortunately, today. But I will have a presentation for you that I want to present and share some ideas and my thought. The last week I did a presentation at NetLDN event, so it is a networking event for network engineers in London where the people meet together, discuss various topics in the industry without like particular belonging to companies or vendors or customers, just to discuss technical ideas. And I decided that it would be interesting not only for this community of the people, but for a broader audience. And that is the reason why I'm creating this video for you. So the topic that we will discuss today is a closed loop automation and how this closed loop automation could help for network engineers to do their job, to do our job. Before going to the details, and we will go in the technical details, and by the end of this presentation, I will show you a demo, how these things that I'm discussing, describing high level are working. We need to understand why we need to have this automation, because it's quite common when you start speaking to the people about the network automation, people say, we need to deploy some kind of Ansible playbooks or Bash, Perl, Python, whatever scripts, and start doing things. That is true, but that is how we are doing the automation. Before doing, we need to understand why we need to do, just to understand that we are doing the proper thing. So, for those of you who are working in the networking industry, has experience there, the main major or operational major categories that we have are listed here. So it is fault management, configuration management, accounting, performance, and security. So altogether, it's called something called FCAPS. So it is a model of the network lifecycle, we could say in this way, or major operational domains where certain tasks are collected. So the first one is a fault management. Obviously, each and every network engineer who is working in the operational role knows that network breaks. Sometimes very often, sometimes very seldom, which is cool, but it breaks. And when the network is broken, we need to repair it as quick as possible. Based on your experience, the more experience people have, the more clear view on how the troubleshooting process should look like. And this troubleshooting process is typically like you need to go to the network element, check particular information, like perform some show commands, collect the information, analyze if it is up, down, if it is 1 or 0, if it is a proper IP addresses, if the access list installed, and so on and so forth. And so you collect this information, and then based on this information, you process just, is it okay, is it okay, is it not? So if it is not, that's something I need to do. But typical, this list of the action everybody has in mind. The closed loop automation could help here, and in the way that if some certain event is happening and you're hearing for this event, so your engine that is doing closed loop automation getting information about certain event, it could launch a response script which at least collect and pre-analyze information for you, just saying this check is okay, this is not. Or even probably to trigger the response action like changing the configuration of RSVP, tunnels, or changing the access list, changing the QoS policy, and so on and so forth. So configuration management is another important topic, and that's our primary goal for discussion today. So configuration management is something where the company builds the network. Depending on the company size and the type of the company business, this could be a very big job. So if you are working in the network operator, I was working for quite a long in different network operators across Europe, and building the network, rollout of the new devices is a quite challenging task because on the one hand, the configuration is pretty similar. So you have similar configuration of the OSPF or IS2S or BGP process, similar MPLS, similar interfaces. The only thing what is changing is like IP addresses, host names, some other parameters, but it's a very tiny amount of information that you need to change per network element. Vast majority, they're the same. So meaning that you could have a templates, and typically the people have a templates that you fill with the data, you create the config, you push to the network element. The point here, one of the points that discussed right now, and say, actively used in different areas like data centers or enterprise network with zero-touch provisioning. So basically, the zero-touch provision, when you bring the device to the site, you connect it to the network, and it is getting automatically some certain configuration script from zero-touch provision server. Typically, it's very basic configuration like create username, host name, create some IP address, probably VRF, some updating some packages if it is a Linux host, and that's it. Using closed-loop automation, you can get not only some basic information, you can get fully operational state of the device being configured without really touching the device. And that is something we will talk today. And if you'll be lucky enough with my lab didn't work again, I will show it to you. So the short topic is accounting management. So basically, it's what is happening in the network. Traditional, in traditional definition, the accounting management is something that was tracked about the billing of the customer. So if the customer consumes a certain amount of the traffic, it should be blocked, it should be shaped. Taking into account the possibility of the telemetry that exists right now, the accounting management is spreading faster because you could build really very complex business logic. Like if your customer has consumed this amount of the traffic, you need to put shaping. If it is more than this amount of traffic, you would need to send automatic message to him, so on and so forth. All this information could be done again using closed-loop automation. And important here is not on some notification that is going to customer. I think it could be optimized without speaking about the network, but rather doing various action that is touching different components, including live reconfiguration of the network. So the performance management is again very important task, especially for the companies, for service providers, where you analyze their utilization of the interfaces. If it is high, you need to start thinking about the expanding. So it's either just build an additional fiber line, buy a leased line, or probably you need to increase the capacity of your router. I mean, install new SFP modules, new line cards, or something like this. And using closed-loop automation and telemetry. So telemetry is information that you could collect, feed the analytics engine based on the information that you provide will create, if some preconditions are met, like some thresholds are crossed, will push some actions. And security management, again, it's about the collecting of information, what is happening, like various syslogs, again counters, changing operational status of the network, which is not like legitimate, and analyzing. So if it is desired behavior or it is malicious behavior, it should be like prevented if somebody is trying to connect to a network element and just making a brute force attack or doing any other unlegitimate stuff. You want to not only notify the proper people, but also immediately to start triggering some action like blocking SSH access or blocking SNMP access to the network element, and so on. What is also important here, it's important for me, the stability of the network. Say, if you have a network and you're fully automating it, so using templates from configuration management part and somebody changing onto CLI level, it should be like kind of an exception. And if it is exception, it should be a certain process of triggering this exception, because otherwise, again, it could be treated as kind of malicious stuff. And to prevent this or just to remove this, there should be certain logic that checking if the network element is not, configuration of the network element doesn't correspond to how it is described in the database, the information from the database should be taken and pushed to the network element. So again, it could sound like, yeah, we could intentionally broke the network again. It might be true. That's why I'm saying network automation is a journey. It's not like certain pieces of configuration elements or a certain code, a certain application. It is a long journey, or short journey, but it is a journey which touches not only technical stuff, it touches also a lot of processes within the company. And obviously, the bigger the company, the more difficult such changes to implement. So it starts with the network. You have a network, and the network has certain information. This information could be exported either using numeric data or textual data. So if it is numeric data, it's primarily telemetry, very emerging, very cool technologies these days, which provide you vast majority of information. It's worked with the YAN model, meaning it is not just a certain sort of the counters. It has a certain logical tree. It has a data model. In legacy world, it is a SNMP. Again, still very actively used, and I think for many years it still will be used. If you speak about the textual data, it most probably will be syslog. So everything that is happening in the network, somebody has logged, somebody has changed configuration, the interface went up or down, the neighboring of the router went up or down, and so on and so forth. So a lot of information that network elements generate. The first application in the closed loop is a collection app. So this is something that could take the proper information from the network. So either using pooling, so asking the network element, give me please information about this SNMP counters or whatever, or something that is just hearing, listening for the pushes for the network element with certain time frame, mainly like syslog, listening for the pushes and just give me. So I'm listening for your syslog message, you just send to me, I'll process it fast. So the collection app might have, you could see various inputs, so using various protocols. From collection app further, the output is typically standardized to REST API. Again, there's not only interface that exists between the application, but probably is one of the most popular used today, very simple, very robust, because it gives possibility to build application using kind of microservice architectures. I mean, you don't have everything in a single platform, like a lot of vendors previously did, and still some is doing, but even big vendors trying to go far away from monolithic approach, but rather deploy all their application as independent, that communicating to each other using their networks or using so kind of communication that would allow to put even probably on the different compute nodes, right? It could be running this application as containers, could be running VDMs. They have very clear boundaries and very clear input-output interfaces, so which is very cool. So the collection app over a certain time frame pushes information to the time series database. So TSDB, time series database, specific database, which are very handy for this task, for closed-loop automation. Why? So when we speak about the measurement from the interfaces, say the interface counter, we always presume that we have same set of the information. I mean, in terms of same set of the interfaces, same set of the counters that we collect over each particular time interval, say or 5 or 10 or 15, whatever seconds we need. So we have kind of table, counters, values. And we have this table just replicating each and every 10 seconds, so that somehow we could analyze what is the graph of utilization of our network interface or our CPU, our memory, amount of connected customers. That's why I'm saying, so this time series database is very useful for such applications. So the first half of our loop is done. The second half of the loop is starts with the communication between the time series database to the analytics app. There are two major types how this communication could work. The first one is stream subscription. You see that information is subscription based. So the stream subscription means that analytics app asks the time series database. So if you get certain type of information, so if you get the information in the syslog database, stream please it to me. I will process information. Meaning time series database doesn't look like which information is coming to the syslog. It starts sending all kind of syslog information to analytic app. So the subscription could be a bit more modified in terms of, okay, we are listening for a certain for certain subset of the information, so not the whole syslog, but syslog only with this policy, or only from this device, something like this. But typically, like the whole syslog information is sent to the analytics app. It's quite low load on the time series database because it doesn't need to analyze anything. Analytic app, the load is high, need to process more information. The second type of subscription is called batch. In this case, the analytics app itself, over a certain time frame, say, or 1 minute or 10 seconds, 30 seconds, whatever you need, make a request to the time series database in the proper querying language. So SQL-like, most probably, depending again on the vendors that you are using for this database. And The request could be quite complex in terms of it's not only just give me some piece of information, but all of the request. So we are looking in this request information produced only by this node and only in this time frame range or only in this value range. So something that database need to process sorry, and send back. So I said two ways, so stream and batch. Then information is processed further by analytic app. And if you speak about the textual information, it's mainly about the parsing text and finding the match to certain regex, extracting some information from this syslog message, say which host has generated this SMTP message to understand, this syslog message, so that we know to which host we need to perform their response action, or any further use information that might be, say, which interface went down, or which OSPF or BGP neighbor come up. And based on this information, we could extract from this syslog message, we are performing some response actions. So response actions typically kind of program or script. It could be Bash script, it could be Python script, could be Golang script, which inside, right, could do a lot of things. It could trigger the Ansible playbook, could trigger the salt, how do you call it, playbook. So it doesn't playbook, but doesn't matter. So it could trigger something to do some actions down to the network comments with certain parameters that we get in. We speak about the numeric value. Most probably it is just comparing the value with a certain threshold value predefined in percentage of the absolute value, and if the thresholds are crossing, you are doing some response action. Again, so it could be like two even thresholds, like the yellow one, the red one, and you do this different actions for these thresholds, like updating the QoS policy, or updating the routing policy, or updating the MPLS tunnels, whatever. So it's pushed down to the network element, and based on the logic that you have predefined, something is happening. If you think about this from the big picture, previously, as of today, a lot of network has a fully distributed control plane. So routing protocol is distributed IS to IS or OSPF. The MPLS plane is distributed, so LDP or segment routing. BGP is also very distributed protocol, so you don't have this centralization. Basically, you don't need it, and people trying to avoid it because if something is happening within centralized engine, you might lose some problem. You might have some problems later because you lose connectivity to centralized way. The closed-loop automation is clear centralization because you're collecting information, you put in this information together, you can analyze this together. So that's why you add additional brain. I'm not saying that you are replacing the brain. No, I'm not a fan of replacing the distributed data plane or control plane. I'm having worked for, say, how much? Almost 6 years or even 7 years service provider. I know that the data plane, especially, or in control plane for the service provider must be distributed. So data center is a bit different world, so there might be more centralization because you don't have problems like a fiber kind of the middle of nowhere, like Durand tractorist or whatever, just cutting fiber optics and like you're effectively losing some routers. But still, I'm absolutely sure that the network should retain the intelligence that they have, the possibility to self-heal in terms of the routing protocols, in terms of MPLS, in terms of using some BFD, BGP, whatever else. But closed-loop automation complements this logic to add something that is not possible to do purely by distributed control plane. If you are following my blog, so for some time frame starting roughly from December last year or January this year, I was building two in parallel, so two main projects. It's a service provider fabric and data center fabric. So what it's about the fully automated deployment of the network. So obviously service provider is a data center. Using their net confiance or model-based approach, or using a standard templating approach using Ansible and Ginger. And I was writing actually what I'm explaining in this presentation. I was writing about this a lot. I was just trying to compose everything for you so that you have a lot of understanding. You could go just for certain piece of information if you need to have a more detailed view on something. And I was building all this project using the open source. You can see that I'm as green as a logotype of the open source community itself, because I'm really a fan of open source. There are a lot of just brilliant products. The only thing you need to understand how it is working and properly integrate. But in any case, even commercial products from the vendors, typically, they are not fitting all the purposes. They need to be tailored for particular customer. They need to be tailored for particular environment and so on. So it's in any case, a lot of work to be done. Just matter if you do it yourself, improving your skills, or done by vendor, improving their skills, improving their also financial situation, obviously, because all the professional services cost a lot of money. But it obviously depends on the company. If the company doesn't have a proper skills to develop open source, the company need to relate to something. And it's why it's cool that various vendors provide a professional service to deploy all this automation stuff. Second point is a microservice architecture. We're showing you there are application, there's 3 application: collection, storage, database, and analytics. Each and every application has a clear boundaries. It's why following the modern, I would say, kind of de facto standard built an application, use microservices, use containers, use VMs to put different application part in different boxes. Why it is important? Because different companies might have a different scaling requirement, or probably would need to have different instance of one piece of application, especially it is really one for collection of the information, like the collection information from a SNMP or telemetry or syslogs or different protocols. Probably would need to deploy 3 different application collectors, each dealing with each particular input protocol, but everybody has the same single output protocol to centralize database. Or again, you might have different databases, sometimes use database, one for syslog, one for telemetry, one for SNMP. So based using microservice architecture, you are free to do whatever you like. You could put everything centralized if you like that, or you could do fully distributed, highly scalable environment if you need it. And the third point, again, is very important. Whenever you think about the application, I intentionally haven't spoke about any vendor name up to this point, and from the next step, I also don't speak about the network vendor, but obviously I will speak about certain vendors because I will show you what explicitly I have done, and I have done some research. Important is, whenever you start thinking about being the automation, I highly advise you to start, first of all, understanding what you need. So you need to listen for the events, fine. Which application exists on the market, again, vendor proprietary or open source, which allows you to listen for this event. How this is done? Is it just a kind of message bus? Is it HTTP, REST API? Is it syslog? So how this is working. And once you have a clear definition what you would like to have, so what you need to do. So you're here for events, fine. How you process events. What do you want to trigger? How do you want to trigger? How you would like to track the output of what you have triggered. So once you define what you need, you go and start looking for the application. As I said, I advise to start at least with open source. Even if you don't deploy it into production, you will have a just enormous experience. Learning curve will be very, very sharp, but very useful for you. You will understand much of how technology is working, and then you could define and decide if open source is for you, or you're not, let's say, brave enough and grown enough to start deploying open source, because open source obviously requires a lot of efforts from the development to build the system and to support it. Something homegrown, it 100% would fit your need, but you need to be sure that you have this time and resources to invest in building your system. So, more precisely to what we'll speak about closed-loop automation. As I said at the beginning, we are speaking about, more precisely, zero-touch provisioning and complement of the closed-loop automation to improve or to extend the zero-touch provisioning. What you can see here again, so microservice architecture, so everything is running in a separate application entity. This is something that is like a free product that I have built on the GitHub. You could go to this link, github/data center fabric. So it's fully explained with a lot of documentation, Ruby files, how things are working, how to trigger them, what they have. Obviously, much more information you can find in my blog. So the whole this system contains about, as you see here, 11 applications of today. It might be even more in the future, but as of today, I don't have that much time to develop it further. Hopefully, I will have in the future. Let's see. What is important here? The application below, so these 4 boxes, something starting with name infrastructure, so infrastructure, DHCP, DNS, FTP, and HTTP. This is the basis for the standard ZTP server. So how typically the ZTP is working? So when you build the device, so when you connect the device to the network, it's connecting to the DHCP server, it's getting IP address. But you know, DHCP is, or if you don't know, it's even better for you, you will know it right now. DHCP provides not only IP address or host name, it provides a lot of options. Certain options, especially there are a lot of some proprietary one that vendors could declare for them, allows you to put like a default software image that you need to have to the network element. It's very often that devices are sent with outdated software images because it was built on the factory some years ago, and even if not some years ago, typically they're not coming from this factory with a fresh image. Typically, you would need to update to the latest one. And what you could do in the DHCP request, you are putting that you need to download the latest software image. Obviously, if you're downloading this latest software image, you need to have something where this image is stored, and that is why we need to have either FTP or HTTP infrastructure, so basically which provide the possibility to put this image. And the standard is set configuration script that creates like host names, probably VRF, or put in some IP addresses, some security patches, whatever. Again, DNS is something also very useful because you don't need to remember all the IP addresses. You could just communicate with the host, or what is also important when you use analytics app or collection app that could request or could try to access certain host using the host name, as a typically host name is part of the syslog message. And that's why if you're trying to access certain host name by certain host name, you need to make a DNS that could translate this host name into IP address. So that's why it's typically also part of the product. What we also have is provisioning. So that's something that's typical for without closed loop is used to provision the network element. So something that you could take. You could think about the provision in a set or their templates that request data from kind of documentation tool and creates in the output of the config, or not only probably creates the config, but also pushes config down to the network element. Response option we'll speak about later, more closer today. So this is something that has information about, or basically this is a response script, so Python, Bash, Perl, whatever you like, which is launched by the data analytics when it is necessary. So when data analytics consider that event has happened and I need to respond. So data collection, storage, analytics, we have spoken about it before. This is something that collects information from the network, SNMP pieces of telemetry, store that, and analyze it. So obviously there is a data virtualization, which network we have without virtualization, so something fancy which shows you virtualization of network interfaces, CPU, again, number of connected customers, used IP addresses in the pool, and so on and so forth. So with yellow, there is something that is related to this particular session today, something related to closed loop. So the other application, those were necessary, and they are built, as said, in this project. You could find a lot of interesting, I believe. Up to this point, we was not talking about any particular vendor, and again, I didn't want to do it from the very beginning because each and every engineer has its own preference, or each and every company has already something bought. I'm not so focused on the particular vendor. For me, it's important the functionality. Here, I put the vendors because I'm describing what I have done. And when you're doing something, you cannot do something with a vendor. You need to do something. So all the products you could see here, they are open source. So for the application platform and for microservices, I have used Docker. I find it very useful and easy platform once you learn about it. Because it provides the possibility to build the containers and to containerize each and every application within one host. You could distribute across different hosts using the Swarm or Kubernetes, whatever you need. Important, you have a network connectivity between the containers. That's why you could connect all the applications to each other. So for the infrastructure level, I was using the Alpina Linux, because it's like the most tiny Linux, the Alpina Linux standard container, just a bit less than 6 megabytes, sorry. The current world of terabytes, it just could be unbelievable, but it is. It is fully functional Linux kernel, and I think it is the best option for the containers. So on top of the Alpine Linux, I would deploy these 4 containers. It's IC, so you know this company. It's very old, along with the market, probably one of the most popular, the DHCP daemon. So it exists for all kinds of Linuxes, Ubuntu, CentOS, obviously. Alpine Linux, for DNS, it is bind9 again. I think it's kind of legendary. DNS server which is deployed in many networks across the world. For FTP, VS3PD, again, something very simple, very quick. For HTTP and JNX, again, very simple web server. These containers are like quite easy. There is an article on my blog that you could read. It's called Building ZTP. So it's about like exactly building this up and showing how you could integrate the configuration of these containers using Netbox. It's a very important point because when I'm working in the network, I don't have time to update manually all the DHCP and DNS, but I know they need to be updated. Otherwise, like automation would not work. And that's why you could read about how to automatically create the configuration of your DHCP, so DHCP-DE file, out of Netbox, or how to create the forward and reverse zone both for IPv4 and IPv6 for bind out of Netbox. You could even provide the detailed example of Ansible playbooks to template all these 4 containers. The next point is provision. So I'm using Ansible. I'm using Ansible roughly for 3 or 4 years already, so it's quite a while. I like it a lot. I find it very easy. It's not necessarily the quickest one. In terms of if you deploy the provision using Python, it might be much quicker, but again, so it's something I'm using myself. Now I'm probably more learning the Python and trying to use it because I like the speed and simplicity of the Python as well. So Ansible is better for people who are not very familiar with programming, who don't want to be familiar with programming because it's very abstracted. Documentation, I'm using Netbox. Very good infrastructure documented thing. So it doesn't contain the configuration itself, but it contains information about the devices, IP addresses, network interface, how they connect to each other. The primary focus is data centers, but basically all the network is kind of distributed data centers. You need to put the devices in certain racks, you connect interfaces to each other. It doesn't matter, the data center, service provider, or enterprise, you have everything the same. For data collection, storage, and analytics, I'm using Influx-Stick, so Telegraph, Influx database itself, and Capacitor for analytics. I know that the latest Influx DB 2.0 release doesn't have Capacitor separately, but it has it like a part of Influx DB. So basically, they have integrated these 2 apps together, but I'm using still not 2.0, but pre-2.0. That's why these elements are separated. For visualization, I'm using Grafana. So you will see some of these tools when you see Grafana today. And yeah, for response, again, either Bash or Python, whatever you're more familiar with. And it's not only about whatever you're more familiar with, it's something what is more applicable for this particular situation. So I'm using Bash. You will see this in the demo today, but Python could be good as well. Or I'm using Bash because I need just to simply launch the playbook with certain parameters. So all in all, what we have, the traditional ZTP is quite poor in terms of you just getting IP addresses. Yes, you could remotely access network element, you're getting host names, some basic configuration, AS and IP, but you didn't get the full configuration. What really makes a difference is that closed loop automation allows you just queuing for certain actions that is happening, or certain events that is happening during the standard ZTP process, to extend this process by pushing the full configuration of the network element down to the network element. So that is how it works, and on the high level. And now we'll go to the details. I know it's probably a bit long session, sorry about that, but I hope you're not that bored. Or I'll probably put some timestamp that from this time we're starting to speak about the particular implementation. So how these things work. Let's say we're building data center or enterprise network or service provider, doesn't matter. It's important that we want to build a new network element. We start not with connected network element, obviously, to the network. We start with documenting. So we build this documentation in the Netbox, saying this network element is connected to this element using this port. So this IP addresses we assign to this network element. This host name, this is it. Software version, this is this vendor. All these parameters are quite important, because the more precise the documentation is, the more probability it will be configured properly. What does it mean? Obviously, different network vendors has a different configuration syntax. Cisco, Arista, Nokia, Juniper, Cumulus, Huawei, whatever, everybody has its own syntax. But from the documentation point of view, it doesn't matter. It's just a box that has certain interfaces, certain IP addresses connected in certain way. And basically, that's it. So that's why it's important not only to document the device, but also to document not only to document how device is connected, what's the IP address, but what's the type of the device, so that provision script could later on take the appropriate template to push the configuration. Yeah, so the second, that's why point where we're launching, we're speaking about the preparing. Sorry, to move somewhere my video so that you see what is happening here. Fine. So the second step is once you document everything in the Netbox, you create the proper template. So it's something that you need to test a lot before you start going into any production. So you need to test it 100 times, 200 times, whatever number of times, knowing that template is 100% correct, it's 100% correct output for your network element, and you could safely push this config down to the network element directly, so that it is really closed loop without any manual intervention. So that's the first and second. That is where we need to work as network element. As the network engineer, automation engineer. The third topic, what is important for this project I was doing, that we configure capacitor, that's a data analytics tool, to listen to the DHCP logs messages. Because, as I was explaining initially, the ZTP process is based on the DHCP. So the server is getting certain IP address and other parameters, and so like download, image, whatever else. It's important that to trigger the whole this automation pipe, so our analytics app here listening for the DHCP message, and when the proper messages come, then it triggers the section. But first of all, we configure to hear for them. So once these things are done, we are just templating the information to the proper daemons. As I was explaining to you earlier, this configuration DHCP and DNS is fully templated, same as for Telegraph. So we template basically which host we need to ask, in this case on SNMP level, and yeah, to push this information. So that container starts properly working. Same for Grafana. So we're adding that certain device should be added to Grafana for monitoring, and this could be fully automated. And that's what we are doing. Once we have templated all the information, we are ready, basically, and we could start deploying this configuration. So we, at this point, attach the network to the network element. We could attach it only to the network, to the management network, or we could attach it to full fabric, whatever we prefer. I would prefer to attach it to the full fabric. And at this point, the DHCP process starts. So we are requesting DHCP by getting the offer. We are requesting it. and we are sending the back the message. So basically, the whole DHCP process works. We collect syslog. The syslog is collected from all the containers. So basically, capacitor is, we have a certain telegraph instance, which is listening for syslog messages from all the containers itself. So each and every container generates logs. This is standard Linux logs. And these logs are collected over the separated telegraph instance and put to separated InfluxDB database. So this syslog is collected from the DHCP server or telegraph and put to the Influx database. So Influx database streaming all this syslog to the capacitor, and the capacitor is listening to the DHCP ACK message. So basically, the DHCP ACK message contains the IP address which host has become. There are, again, so various reasons, not various reasons, or various options how you could create this closed-loop automation, but typically for ZTP, you would like to provide a certain IP address to certain network elements. So this is typically done by a fixed binding of MAC to IP address, and this MAC to IP address could be documented in Netbox. It's why, as we were showing in the beginning, when we template the configuration of DHCP, this fixed list is created. When I was presenting it on NetLDN, was getting the question, yeah, but you need to have MAC address. Yes, you need to know MAC address. Typically, the MAC address for management interface is provided somewhere outside of the device, like just a sticker or an admin, or even probably once you could start like booting it up, you will get some messages on the device, and you could automatically configure another automation or this switch, again using Closedloop, something that if ports goes up, you collect the MAC address on this port, and in the documentation tool you would know that this port is connected to a particular new network element, and I need to update this MAC address in the Netbox for this network element, or to automatically trigger the full reprovisioning of these guys. I mean, when you start thinking from this perspective, you have endless possibility to make the whole network stack automate. So DHCP ACK comes to the capacitor, and capacitor triggers the action. So, as I said, the capacitor extracts the certain IP address, which is contained in the DHCP ACK, and launches the Ansible playbook with this IP address. So the playbook I have created in the way that if you don't provide any kind of IP address, it provisions the whole fabric. If it has certain IP address, it provisions only this host. Now, the question that I got, and that I have this myself when I was developing this product, do we want to reprovision in the other device that is happily running over the years, or months, or weeks, whatever? Obviously, this question would be no. Or yes, because most probably you would need to configure this interfaces facing this network element. But again, it's something you need to think about. How do you treat the network? So basically, I was doing some checks. The device is not provisioned if it is in certain state, because Netbox provides you opportunity not only like to document the device, but also document its state, if it is planned, if it is active, if it is staged, and something like this. So then, as said, the capacitor is triggering the response action. The response action, in my case, is bash. Bash is launching the Ansible with this variable got from the capacitor, so IP addresses. Ansible requests the data from the Netbox about this particular device and pushes the configuration towards the switch, so the switch has a full configuration. So, device is fully operational. It starts collecting the whatever information we have, so logs, SNMP, telemetry, whatever we have. Well, this is how this the whole automation stack is working. I will show you right now again. I hope this lab would work, it will not break again, and you will see how it is working. why I'm saying why it's not breaking again, as I haven't shown anything yet to you, because when I was trying to present this live and that of the event, I had some problems with internet in the venue, and it didn't work because one of the points the lab was creating of the containers. I mean, really deploying the containers out of images, it requires some information to start from the internet. So I have better prepared this time, and I have already pre-built all the containers. So basically everything we was discussing today, all these wonderful containers with infrastructure, with monitoring, provisioning, and so on. And you will see from the state that, as I was discussing, the lab is prepared. Let me share the VM with you. I need to change another window for this. So here we go. You see the end of the final execution of the Ansible playbook. You could see plenty of tasks that were performed. So 122 tasks in total, 92 did some changes. Let's check what containers we have. So we could see them using this command. So you see containers up and running for quite some time, a lot of information. What's important, if you're not familiar with Docker, it might be a bit difficult for you, but what is important, just to sum up, we run all these containers. So these Netbox containers, there are 5 actually that compose the Netbox itself, and then all the containers that has a DCF in its name. This is the containers that I was creating and building, so all this infrastructure components. So we have HTTP, FTP, DNS, DHCP, the infrastructure containers. Then we have 2 telegraphs we're discussing, so one for SNMP, one for syslogs, InfluxDB, Grafana, and Capacitor. So all these containers create the stack, and all of them are up and running. So before we start, we don't have any kind of VMs running with software, I mean with network elements which would emulate or which would trigger this provisioning. It's important briefly to take a look on their capacitor script with which actually do this parsing we was discussing beforehand. So it uses specific language. It's called TIC script language. It is based on the Golang. You can see that it has certain pieces of software. So the first one is a stream. So stream means this is a strip subscription. You remember I was discussing at the very beginning that the information or the syslog messages are flowed from the TSDB to this analytic app. Then within this stream subscription, we have a so-called node. So nodes is basically a piece of the software or a piece of the logic that do certain actions. So the first one from its is basically filters which information we need to have. So we say that this information coming from the syslog message database with retention policy out again. It together creates the subscription. So this subscription, the CF syslog out again is listening to. Within this information that is coming up, we are looking for a measurement called syslog. So basically all the syslog messages. And then we do a text parsing. So we are looking for the messages that is called, or which has in its string, so in field message, DHCP, DHCP value. So basically the syslog messages are generated by the container with the DHCP. And with this, within these messages, we are looking something starting with DHCP in the beginning. So this is our trigger. If these conditions are met, so both message ID and message, then we go to the next step. The next step, or the next node more precisely, is called log. It is typically used for the debugging, so I was using to the debugging that the message, once it is found, it is logged to the syslog of the container itself. It's very important for when you develop the scripts, but not necessarily for production ones. And once the next point, so basically is do nothing, only logs. And the next step is the alert. Alert basically says, so if we so if we have a certain condition, like critical condition for us, we found DHCP ACK in the message that it is triggering the fuzzer action. The action is this bash script which do some actions. We will go in a minute to this bash script, but before going further, we could look to the following. So each and every node shows kind of number of elements which were processed. In this case, you could see the 2070 messages is the all amount of the syslog messages processed or streamed to our capacitor node from the database. The rest is 0. Basically, it means that none of the actions or none of the hits for these nodes were done, basically because we haven't received any DHCP messages which contains DHCP ACK inside. So one important point, so before we discuss the structure of the Netbox database itself. So this is, you could see, interface of the Grafana. It's visualization of all the syslog messages that are contained in our time series database. This you see, this first field is message ID. It's actually the host name of the container, name of the container that we are looking for. It's one field. The second is message. It is actually the actual content of the message, which we are parsing within our application. So just to close the topic on the capacitor, another point is the bash script itself. I'll show it to you guys. It looks a bit heavy, but what's it doing? It's pretty simple task. So by this very complex construction, we are just parsing the DHCP ACK message and subtract IP address. So this IP address is stored temporarily for a file. Probably there is a better way how we could put the IP address to wire, but I'm not yet an expert in the bash. I'm just learning the way how I found it could be done. Then we are just sleeping for 60 seconds. We could remove it, so we could start immediately. But so I think it is for my exact purposes, it is fine that we do a pause here. So once this pause is completed, or we start the actual processing. So we import this, the input of this file, which is that the IP address that contains in the DHCP ACK, this IP address that the network element, new network element has got. And this IP address is used later on, as you might see here, to trigger the Ansible playbook with an extra variable. So basically, we are triggering the standard provisioning playbook with a variable that this is IP address. So if this var is presenting, so there is check within the playbook, it launches the playbook for this particular IP address. So it requests the Netbox. I have this IP address as a management. Please give me the host or all the information we have for the host that has this IP address as a management, and therefore the provision in launch only for this particular host. Beside that, we also doing some time stepping. There is a capacitor host name just for the login. What is also important, we are doing the login. So you see login at the start of the provision and login at the end of provision. That basically shows how quick our provision is working. It's important that we understand what is going on. So these logs are put on our main host, so on this VM where all the containers are running. So it's not within the container because the Ansible itself is not containerized yet. In this deployment, it could be, but it is not containerized, and it is running on separate host. So having said that, let's take a look before we would see exact process of the operation of the Netbox, also of the closed loop automation and zero touch provisioning. Let's take a look in the Netbox. So Netbox has this state right now. So we have 6 devices that are planned to be provisioned. It is 4 leaf switches and 2 spine switches. All of them on the planned state. This is important. The playbooks, not the playbooks, the whole automation that is created, it relies on the rich functionality of the Netbox. So the planned state means, or is important for us, that from the playbook perspective, it means the device is not yet provisioned. So, and it checks. So if I got some certain IP address, so from this DHCP message, which is processed by the analytics ABAC as a capacitor and triggering the later on bash script. So it makes a request to the Netbox and say, this is my IP address, or this is management IP address of the device I want to provision. What is the state of the device? If it is planned, fine, meaning this device is not yet active. Get me information, I will provision it. If the state is not planned, so anything else, active, staged, offline, it means that something is wrong with the device, or probably not the wrong, but the status is not corresponding to the one that is used for provisioning. That's why I probably would need to avoid provisioning the device and don't do nothing. So we could just drop inside. We see some information about, so this is step of the Dell switch. Basically, it's just a cumulus switch. It's important which platform, because this is used for choosing the proper template. So in this particular case, all the examples about the cumulus, but in the project itself, you could take a look on my GitHub page for this data center fabric project. There is also templates for Arista, for Cisco, and these templates actually, and this platform means that I would, the playbook would choose the proper template to provision certain network element. So inside we have IP addresses, or that is MAC addresses as well. So it's mapping of MAC to IP addresses. That is important because this information is used to provision the DHCP server that is running as a part of the data center fabric stack. Connectivity to other network elements. So you see the Spearlink. So we have a bonding also interface, which is necessary for the leaves when we speak about the high available deployment with multi-chassis LAC and so on and so forth, and IP addresses that devices peering to each other. So the basic logic, how the playbook is created, we wouldn't go into the details of the playbook this because it's a completely separated, very complex topic. You could again take a look on my GitHub page. The point is here that if their peering interface is facing another switch, so leave for the spine, depending on what we need to do, to all the spines element, it will automatically build all the BGP neighboring, because obviously we're building the fabric. We don't need to say anything about, we know that by default, leaf, spine, exit, or border, whatever we call their leaves which are facing the routers, these interfaces must run BGP, IPv4, and EVPN at least. I mean, from the data center perspective. So this is how our information for the devices look like. Now we could start the VMs with the cumulus switches and take a look how this would result into provisioning path and into their changes later on in the Netbox itself. So I will launch right now the certain VMs. So the VMs are starting. I think I need again to change the share, what I'm sharing with you, dear friends. So I will share with you view of one of the VMs. So this is a VM with the cumulus. You see it is booting. So it takes some time for VM to boot. So if we go, oh, too much. Inside this VM, I hope no. I have tipped the false password. I think I have again tipped the false password. No, it's quite complex, the full password. Finally, I'm in. I could briefly show you configuration. So you can see there is a standard configuration, nothing related to the routing. So we have only time NTP, so even no routing is configured. The only thing that is a name server, but is by default part of the ZTP template itself. Now so the process has started. I need to switch my share back. Sorry, I'm just jumping between the images, between the VMs, because I need to show you how it is working on. So if you take a look to the DCF, to our, Grafana, we could take a look. So here, should we see some information about the DHCP? Yes. I think I have saw somewhere the DHCP messages. So I need to scroll. Yes. So this for too many messages. So basically, this is the DHCP ACK message. This is a message that triggers, as you remember, our capacitor script. So this message comes to syslog. If we see it in Grafana, meaning the capacitor has received it as well. Remember, I was showing you the information with our script. So basically, the details of the script. Let's take a look on this again. With the tick script, you see that the number of the second nodes become like 6, and the number of the logs become like 6, and the number of the alert triggered also becomes like 6. Critical 6. So it's meaning that this message, we have 6 VM launched, 4 leaves, 2 spines. So all these things are properly processed by this tick script, and they have launched this closed-loop automation process to complete the zero-touch provisioning upon it. So I was showing you in the bash script there is a specific part that is doing logging. So let's see. Yes, we have now the specific folder called logs. Let's see what we have inside. So the log is deployed in this in such a way. So there is a name of the container. So that is the container which is running capacitor right now. You see that provisioning has started for IP addresses. Those IP addresses, as you remember, it's extracted from the DHCP message. So then the DHCP message triggered the whole capacitor script, and this IP address as a variable passed to the Ansible playbook. You see Ansible playbook start configuring. So we put the host name. Why it's important that host name is here? Because so it's already like showing that the proper host name is found in the database in the Netbox. So the management IP address of this device is this, and once the provision is done, so you could see that it takes roughly about just 1 minute to provision one network element. The provision is done. So we had a 60-second sleep. So meaning there will be typically 1 minute before next iteration. So I was talking to you. You could see that the provisioning for second network element has started. So it is completed. You could see that the timing is exactly like 1 minute, exactly this 60 seconds pause timer. Now we could switch to another or to any of these provisioned VMs with the Cumulus, just to see, to show you that it is really provisioned. Let me find the proper one. I think it is this one. Yes. As you can see, initially there was no that much configuration. We just run the same commands again, and you see there are a lot of configuration. You see the interfaces, the peer link. You could see the IP addresses of the interfaces towards the spine. You could see the CLARC. You could see the IP address. So everything what we need to get the device to full operational state according to the information documented in the Netbox we have here. Right, so this was focused mainly on, the templates as of today, they are focused on to create the full underlay fabric, but it's just a template, meaning it is a Jinja file that you could extend further to put not only the underlay, but also all associated Wix, lines, VLANs, whatever you need, what you can document for this network element. So, what is also important to say here, what I was mentioning, the device is provisioned only when we have a certain state. This state is planned. Sometimes I have seen during the developing of this playbook that some devices, for whatever reason, was asking DHCP, DHCP process was running twice, and it led to the point that device was running. So the script was 2 times looking for certain IP address. So the same IP address was 2 times requesting inbox and 2 types provision device. And second provision was even sometimes within the cycle of the first provision. So to avoid this, I deployed the checks for this status as a network element that it should be in the planned state. So as you see, everything was planned. Let's update this the page. So you see 3 network elements are in the active state right now. So the logic of the Ansible playbook, that once it is provisioned, so all the tasks are successful, the last task is to put the or update the information in the Netbox for this network element to put its states from the planned to active. So meaning the device is back, right? Why is also it's important? So bringing the device to the active state could be working as a trigger again. Closed loop automation is just engine. You can deploy whatever you like. It could be the trigger that, okay, if the device is in active state, we need to add right now information to proper capacitor, sorry, not capacitor, to the telegraph. We will start requesting the information. So SNMP, telemetry, syslog, whatever from this information. So we update configuration of the telegraph, and it could also be as a trigger for the Grafana to create a new panes or new tabs, new graphs for certain interfaces, like utilization of the interface or CPU utilization or something like this. So this states is an additional, I think, very useful capability which Netbox provides you to build further all the automation. So for the we were discussing, we could just take a final look. We have 4 devices provisioned, so all the leaves. Let's take a look what we have here in the log. So yes, we have 4 devices. Just 1 more minute, we would see that spine is provisioned, and I will be able then to show you the full GPU I think is up. Which is very useful. Again, so here we provision the full data center, meaning you could document and like design the full data center using the Netbox. And once you make a greenfield build, you would just need to prepare the full stack on site or remotely, whatever you could build. And after that, you could just ship the devices there, wire them properly, enable the power, push them on, and just drink a call for 10, 20, half an hour, minutes, and we have a fully ready data center. I'm just waiting for, yes, so one of the spines has went up. Let me briefly show you it again. So this, the same lift what we was looking before. Let's check the neighbors. So you see that one of the neighbor is up, so it has 4 prefixes sent. And if we check, yes, you could see the IPv4 routes that was learned from the core, was learned from other leaves. We'll also see some IP addresses associated with IPv6, also something that was learned from the network elements, and that's it. So your fabric is there. You can take a look also on the EVPN, because it's like a basis. We have zero routes because we have no services associated with it, but what is important, that the fabric has appeared on the proper BGP address families. So that's in a nutshell how closed loop automation is working. We have an event. Event is triggering some action. So in our case is a bash script. Bash script has certain logic inside. So it's collecting information from the mail, from the syslog in our case. So it's collecting some information. It depicts the most important piece of information which could be used later in the variable. And then our bash script are running the Ansible playbook with this variable to ask the Netbox for the information, put this information in the template, create configuration, push the configuration to the network element, bring it to the fully operational state. So going back to our presentation, we just have 2 more slides that we would need to cover. All in all, when we speak about the network automation, this is not something super complex, because on the other hand, it is super complex. But to make it easier, to make it understandable, and to make it really valuable, you need to start with the first step. The first step is understand your business logic. Your business logic, you know, it's kind of a term that is used a lot in various marketing speeches. I hate such kind of speeches, or you could argue I'm using this word here myself. What is important here, you have a certain understanding of your network. You know what you need to do by the troubleshooting. You know what you need to do by provisioning your network element. You know what you need to do by extending the capacity. So you have all these scripts in your mind. So you do this, this, and this. So this is your business logic. So you know what you need to do when. So this is the first point. The second point is you know what you need to do, so which steps you need to take. Therefore, you need to understand which information you need to collect and how it to analyze to come to the final decision. If you think about this in the abstract way, so information that you collect is your variable. So your steps, what you are doing is your script. So it's exactly like playbook. Information you collect from the network is a variable, you put it into the BGP logic with your template, and together you create the network automation, which is ultimately related in certain steps which your network needs to do. So finally, when we speak about the network automation, somebody could call it as a magic, maybe. In reality, it's just automation of knowledge, of your knowledge as a network engineer, of your tasks, and nobody besides you could do this. Obviously, a lot of companies provide here consulting, provide some ideas, provide professional services, but there is no one size fits all. Typically, all the companies, all the vendors provide a product that needs to be tailored. And as we were discussing earlier, it could be tailored by them. If you don't have enough experience, or you don't have time, or that is not your core business, or you could also use open source if you have more time, if you have more skills, or if you could invest and develop yourself further in this direction. Because all in all, it should be tailored to the particular network element, and to particular network, and to particular processes, especially in the network. Thank you very much for your attention, guys. Really appreciate you say me anything in the comments, or just like the video, repost it, and see you next time. Thank you very much. Bye-bye.